engineering. I'd like to get deeper into that field. I feel like they're pretty complementary. So here's what we're going to be talking about. First of all, it's the easy tricks. No configuration really needed. Talk a little bit about proxies and VPNs, SSH tunnels, very useful thing to have if you have no other things to get around. Different protocols you might want to use to bypass certain firewalls. A little bit on how to evade DPI. So a lot of the firewalls nowadays will have more advanced features to try to detect that someone's using a VPN and so on. So I'll teach you a little bit about how to get around that. And then final trump card is domain fronting. And if you're a pen tester, you probably know what that is. If not, I'll show you. It's pretty cool. Anyway, we'll get started. So first of all, you can use web caches. So if a certain website is blocked, you can go and fetch the page from another site that will cache that page, primarily for performance reasons, sometimes for archival purposes. So here's our good ones you can use. You can see, you can type in that URL and then the site you want to go to, and then you can usually access a cache page. And the firewall will just pick up googleusercontent.com, which is definitely not going to be blocked. So that's one way you can do it. One caveat about it is that some archive sites aren't super up to date. Sometimes it's a week back, 2 weeks back. For popular sites, it's a few hours, and so on. For new sites, you know, sometimes you'll go to a site and then it'll be blocked, and it'll make you pay for it, pay $5, something like that. You can use a service called outline.com. What they do is basically take the page and then spits it out to a format without the ads, formats the text properly, and allows you to highlight. Well, you can use that to read stuff that has a paywall. It's always going to bypass that. Now, not all sites are supported. I think after a while they got cease and desist. So sometimes you'll put in a URL like Financial Times and then it'll say not supported. One way you can get around that is by taking that Financial Times link and then putting it into a URL shortener, so like bit.ly, and then putting the shortened URL into Outline. Then you get around it that way. So that's pretty helpful. Yeah, another thing you could do is use Google Translate for certain pages. Helps if you're bilingual, I guess. Yeah, just paste in the URL. Another thing you can do, well, the problem is you can't translate English back into English. So you can usually copy the translated text and then throw it back through the translator. That works well. Certain languages work better than others since they're linguistically close. A little bit about how paywalls work in the first place. So usually you have some sort of cookie, some sort of user agent tracking where it'll identify you and then make you only be able to read 3 pages or so. So sometimes you can just straight up clear the cookie from your browser or open up an incognito panel and then it'll bypass the paywall that way. There's also a neat Firefox extension that does this stuff automatically, just transparently. Works pretty well for me. Next thing that we could do is proxies and VPNs. Now, those typically will take a bit more setup, and even content providers are getting savvy to this trick, so they'll detect if you're on a VPN based on the IP or known list of IPs that are associated with VPNs and will block you. So what you could do instead of buying a VPN service is to roll your own. I don't know how reputable a lot of these VPN companies are. I mean, it's such a cash cow that they spend so much on advertising and you still don't know if they're going to give up your name or not in the event of a subpoena. So one thing you could do in order to roll your own, well, first of all, has anyone tried to make your own VPN using OpenVPN? It's hard, right? Yeah.
It's not fun.
No, it's not fun. The config sucks ass. It does.
Which config?
What do you mean?
Yeah. So there's a cool project on GitHub called Streisand Effect. And basically, it's just a bunch of Ansible scripts that will spin up a server in AWS or Google Cloud, and any cloud provider really, almost instantly. 10 minutes, it'll build it up, generate fresh keys, and then have a site where you can access the different protocols that it supports. Highly recommended. You can even pair it with any cloud provider. Typically, the cloud providers will almost always have some sort of free trial service where they'll give you a bit of credit that you can use. And oftentimes, this credit is enough for you to run a few VPNs, and so you can make your own network relatively quickly. And because this is an Ansible script, you can spin up 10, 5, 20, however much money you have onto different cloud providers. It's literally all you do is take your API key, plug it into the script, and it'll build everything for you. Highly, highly recommended. So once you've built it, you can have a home page with configuration options, and you can pick from different protocols, OpenVPN if you're used to it, SSH, whatever things are open on the firewall, you'll just use that. So it's helpful if you have a domain associated with some of these. So the reason being is if it's a raw IP, a lot of firewalls will try to block that or flag it as suspicious. So typically you'll want to use a domain for it. Certain IP blocks are just known DPS services. So a lot of the times it'll be flagged suspicious just because of that. A lot of firewalls nowadays will block new sites, like domains that it hasn't seen before, and give it a waiting period. And pretty effective in blocking malware, but you want to get around this as well. So one way you could do that is to use the site expireddomains.net, and then just look at domains that have just barely expired. So for example, projectpool.org, that was registered in 1996, and it just barely dropped. I guess someone just stopped paying for it. But the point is, there's tons of backlinks, there's a long history of the site, someone used it for something, and so on your firewall block list, it'll typically be flagged as good. And so if we actually look at what this is on FortiGuard, it'll flag as health and wellness. So you can kind of hijack that reputation for your own VPNs. Another thing you could do to get a clean IP that's not associated with the VPS is to use one of these proxy network services. Typically they sell these out to web scrapers. And you can actually get an IP from someone's residential address, their phone IP address, and use their connection. You're probably wondering, like, how they even get these IPs in the first place. And it turns out there's other services, free VPN services, that actually they hijack your connection and then sell it out to other people. Oh. Yeah. So don't install that. The other scary thing is the other scary thing is some other things that they'll do is on certain apps like games, for example, those video ads that you'll play in order to get to the next level. Sometimes they'll hijack that connection and then use it momentarily as a little proxy for someone else to use. It's all right, because I guess you agree to the terms and services. Okay, another trick, SSH tunneling. SSH tunneling is super useful because most things will allow SSH through. It's just the de facto standard for web administration. You can point it to different ports. It's super versatile. So typically in a firewall, you can SSH out of the firewall through the firewall, but you can't go from outside the internet back into your network. So we can kind of abuse that trust, right? We have egress, we can't have ingress. Well, we can initiate a connection, egress, out to a different server. For example, our Streisand VPN server that we spun up. and then provide a connection back. So this way, any connection is going to be tunneled through this tunnel, even if you can only go out one way. That's pretty useful. The command line option is TACD for dynamic port forwarding. There's some other port forwarding options, but D is probably the one that's going to be most useful. You can also do it in reverse if you want to get into a network and then access internal sites. You can do that as well. I think the flag is TAC-R, and you can look up the syntax. This is really useful because typically corporate sites, you're at work or something, typically they'll have PuTTY. PuTTY can make a SSH tunnel, I guess, forward a particular port, and then on Firefox or your computer, you can configure all the connections to use that proxy. So it's like you're running a proxy on localhost and connecting to that, and then all the other connections go out through the SSH tunnel. So that's one way you can quickly get around stuff. Typically, you want to move SSH to port 443 or 80 instead of 22, just so it blends in with the other bits of traffic. If you're going to configure on Linux, super helpful to use SSH config. It's just a little file that can specify all the options that you normally provide when you're typing this out. So right, so instead of typing out a long command line with different options, TAC-B, TAC-V, and so on, you can just specify this, and then it'll load this config. So pretty useful for any system administration, really. Say if you have a tunnel or a proxy network running on localhost, you can use a tool called proxy chains to route just specific commands through. So if you have some sort of proxy combined with an SSH tunnel, you can use proxy chains to tunnel just one command. So if you want to nmap through that Bastion host, you can do that. You can do stuff like this. Another thing that's helpful is SSH tunnel. So proxy chains will proxy just one command over, or proxy the entire Firefox. The SSH shuttle will allow you to tunnel all the traffic through. SSH shuttle is really useful because typically you don't require administrative rights on the computer you're connecting to. If you're a pen tester, sometimes you'll land on a box and all you have is SSH. You can use this binary to tunnel your connections through VLANs if you wanted to as well. If you're going to be bypassing certain firewalls, it's going to be good practice to only tunnel lock traffic or traffic that they don't want you to see. You don't want to tunnel all your traffic over because it's pretty suspicious if anyone's looking at the logs. It's like there's only one session, tons of data is coming through that one IP. You can spot it out extremely quickly. If you only tunnel certain bits of traffic, then you can blend in a little bit more. How many of you have heard of WireGuard? Yeah, so WireGuard, pretty awesome. It's an alternative VPN protocol. It's going to be merged into the Linux mainline kernel, and the configuration is dead simple. All it is just a private public key and then a few IP addresses. So way, way easier than OpenVPN. It's also really, really quick. Like I reckon you could even game on it. That's how good the latency is. The other thing that's helpful for staying underneath the radar is WireGuard will not send out any traffic unless there's a connection happening. So if you just sit still, there's no keep alive.
If it's too crowded or warm in here, we set up another room, and we're also streaming that. So if anyone's too claustrophobic, feel free to go right around the corner. fit at least 10 or more people. Just wanted to throw that out there.
Do you slide them all? No, just kidding.
Yeah, anyway, WireGuard is very quiet. You can blend into traffic because it's not a noisy protocol at all. One technique that you could use to try to detect if someone's using a VPN is to identify long session connections. So typically in TCP, you'll have an acknowledge packet, synchronized packet, and then it ends with a finish packet. Well, you can kind of measure that out and then look for really long sessions that are not terminated and just identify the outliers, and you can typically point out, oh, this person's probably using a VPN, this person's using some sort of alternative protocol that we don't typically see in the network. So if you guys are familiar with Zeek, it's kind of like the IDS where you can configure things. I'm sure typical commercial firewalls, next-gen ones in particular, will have this feature built in somehow, but this is typically how you do it manually. Another thing you could do is to use the protocols that the corporate network is already using. So we know almost every modern firewall, every modern corporate network is going to be using some sort of VPN. Cisco is very popular. So you can use their protocol, and hopefully the network admin just let everything through. So few ones you can use, AnyConnect, which is Cisco's proprietary one. There's an open source one called OpenConnect that you can use. It's included in Streisand. I32, PPTP will also work, and you have different port options as well. One trick that's useful for identifying what ports are open is to use I think it's by Black Hills Information Security. They have a website called ScanMe or something. I'll post a link later. But all you can do is nmap that and then see what responds back. It's just going to respond back to any port. So you can quickly identify what egress ports, what ingress ports are allowed. So that's a quick way to determine what port you want to use for a particular service. If you want to be really sneaky, or if it's a really high secured environment, you can actually use DNS to tunnel your traffic through. So, for example, there's a project called DNSCat that will allow you to create a localhost tunnel to a particular site that's running the client, or the server. And once you have the localhost tunnel, you do the same process like with the SSH tunnel, where you configure your browser or configure proxy chains to route commands or other traffic through it. So that's how you specify it on the client. I think the other one was the server. And like I said before, right, I'm using curl just to test out the localhost tunnel that we've established with DNSCat and see if we get a connection back, but it's tunneled through there. Now, let me show you one more thing. Right, so this is what the DNS tunnel traffic kind of looks like. DNSCat will encrypt it before sending it out. But you can see it's using the host headers to tunnel traffic through. Very noisy, but it totally depends on if the SOC is monitoring for these things in the first place. I mean, a lot of corporate environments don't even monitor DNS traffic in the first place, or maybe they don't even have analysts looking at it. So here is an example of what the setup kind of looks like. So what we can do is, if you're on the inside of the network, we can use their internal DNS servers to talk to the outside world. And so the reason why this is so effective is that the people watching the SOC, people watching the logs, can only see there's traffic between your client and then their trusted DNS server, their internal DNS server, the DNS server then relays out to your server, so your Streisand server, for example. So typically, they're not going to look at this connection, and you can get around firewalls that way. Another thing you could do is use ICPM ping in order to traffic data across. So here is the datagram of ICMP. There's actually an optional payload, and you can stuff data into here. So here's kind of what it looks like on Wireshark. You can see we can shove little bits of extra data through that thing. So there's a project called ICMP tunnel that works the same way as DNSCAT, works the same way as SSH tunnel, establishes localhost, you proxy things through it. If you're familiar with the internet stack, ICMP is actually below TCP, below UDP. Sometimes firewalls won't even look at that. Depends on how the network admin configured it and whatnot. But it's probably going to fly underneath the radar. Not the quickest protocol to traffic data across, but it's good for a C2 at the very least. So this is how you set up a server, and this is how you set up a client. It's super simple, and again, we're using the localhost tunnel to tunnel traffic through. So, other thing, DPI stands for Deep Packet Inspection, and so what that typically is say you're on a corporate network and the corporation issues you a laptop. Typically that laptop is going to have a SSL cert that they've established. And what they'll do is any traffic that gets sent out, they'll open up the packet to read it and decrypt the packet, read it, and then encrypt it before sending it back out. And the advantages to that is that they can have finer control over what to block and what to monitor. So there's a few different types of DPI, but we're mostly just going to focus on the pattern matching type. Port-based stuff is really easy to bypass. Just move to a different port that's open. Protocol decoding is a bit trickier, and statistical analysis, that's like the thing that we were doing with Zeek before, identifying the longest sessions and then blocking that, or at least alerting on it so that someone knows. So yeah, here's an explanation of how it worked. I think I got ahead of myself, but it's worth going through it one more time with the diagram. So typically traffic will go through, it'll open up the packet, decrypt it, and then send it back along. It's basically a man-in-the-middle attack, but sanctioned, so people don't call it that. So the one we're going to focus on most is simple pattern matching. So if you want to identify a particular bit of traffic, say this, for example, this is the beginning of a Skype VoIP call. All you do is try to match that, and then that way you can flag a certain bit of traffic as Skype, as malicious, as whatever. It's just regex matching. So one way you could get around this simple regex matching is to fragment your TCP packet and then obfuscate some of the things that come through. So for example, if we're just regex matching on, say, facebook.com, we want to block that. What we could do is split up this and then make it uppercase, lowercase, split this up into 2 different packets, add in extra spaces. The browser will handle it just fine, but maybe the firewall wasn't. So this is a good way to get around it. It's known for a while. There's a few projects that will help you do this. This one's a Russian project. This one's also a Russian project. There is an English translation of the README, so that's also helpful. So that trick works for Russian firewalls pretty well. I don't think they're super sophisticated, but the Chinese firewall will actually reassemble that packet back together and then match on that. It takes more computational power, but I guess the Chinese have more resources to throw at the problem. So if you want to get around the Chinese firewall, there's different tricks that you can do. In China, they're pretty strict about using VPNs. Even if you roll your own, there's a fair chance that it'll be detected and then blocked. They even block most VPSs in the first place, so any traffic that goes out there will be flagged. And even if you get a working VPN, maybe it will only last 2 weeks or so before someone finds it and flags it. So one trick you can do to get around this is, well, let me go over how this firewall will block you. So it's not going to be an inline thing, but if the firewall detects you're connecting to a bad site or a censored site, it'll send a reset packet to your computer, and then your computer will comply and drop the connection. So sometimes you can get in for a little bit, and then it'll drop you. So one trick to get around it is by desynchronizing the sequence control blocks. So let me try to explain this in a better way. So in TCP, there's SYN, SYNAC, and ACK, and then a FIN flag. ACK stands for acknowledge, synchronize stands for synchronized sequence numbers. And what the sequence number is just a way to expect a packet coming across. So if the initial sequence packet is 1, the next one's going to be 2, next one's going to be 3. And you have to do this because sometimes you'll send in tons of packets at the same time, and they're not going to arrive in the same order. So this is a way to reassemble it back in the right order. Now, what I was saying before with the FIN flags, it's just an extra sequence down here. So what you can do if you know you're going to be blocked is to preempt that FIN flag, send FIN flags back to the firewall with an out of sequence synchronized number. And so what can happen is if there's a FIN flag here, but it says 454, it'll actually reassemble up here. So the firewall thinks that they've already blocked it by sending out those reset flags. There's a good paper on this that explains this a lot better than I could. And there's also a GitHub project that will help you do this as well. I think they designed it specifically. Yeah.
Hey, Kevin, can you repeat back on the something about sending out the FIN flag before? I mean, can you go back to previous slide?
Yeah.
And usually we rely on you mentioned about the sequence number and the FIN. So can you explain this? Because I don't get it, what you're trying to do here.
Okay.
I know the normal behavior, but I'm not sure what are you trying to fool the system. But you're sending a FIN flag before you to the firewall. So can you just please explain again?
Yeah, sure. Hang on.
You're desynchronizing. Oh yeah, the TCP. Okay, so we're trying to confuse them. Okay.
Okay. So typically when a packet is sent out, it has to be sent out in a particular order.
Correct.
The way the Great Firewall of China will try to block connections is by sending a reset packet. So the reset packet is what will drop the connection.
Okay.
Now, once it sends reset packets, it'll send a ton of them at the same time. Maybe if I have a sample of what that looks like. No, I don't. It'll send a ton of them at the time and then stop sending those reset packets once it's there. So I guess what you could do is to send SYN and reset packets with the incorrect unexpected sequence number, and it will confuse the firewall because I guess the firewall keeps state of what the sequence numbers are. And so if you send them out of order, it'll preemptively send those reset packets, but they won't be acknowledged by either the server or the client. And then it'll stop sending those reset packets. Does that kind of make sense?
Because
Yeah, it
the
makes sense.
reset
So
packet
you're
itself is
trying
out of
to confuse,
sequence.
yeah.
Either the SYN or the reset packets are out of sequence. Right, so we'll be ignored
So
by
just to
the-
clarify, are you saying that the reset packets get sent in the beginning and then your connection finishes and then it's kind of like it was sent preemptively and then your connection sustains? after
Yeah,
that?
exactly.
All right.
I think that's, yeah. Okay. Hope that makes sense.
I don't do that kind of stuff, by the way, so I don't know anything about it. Seriously. It might be easy for OSCP guy, so. Thanks.
Yeah, no problem. Another thing you can do, and this works specifically for Russian firewalls, is just to ignore the reset packets in the first place. And obviously, if you drop all reset packets, then your internet's not going to work. You're ignoring the protocol. But for Russian firewalls, it seems like there's only 2 valid IDs that come from the firewall. So if you just ignore all reset packets with that particular ID flag, you get around it. Tell you a joke about UDP, but I'm not sure you'd get it. Okay.
That's a good one, yeah.
My point is the reset packets rely on keeping state. You know where you're coming from, what packets came before it, what's coming after, and where you are in that connection. TCP is really good at that. But what if you use a stateless protocol? Then you can't do the reset things. One thing that is stateless, UDP. If you guys don't know what UDP is, it will try to send all the packets at once, and there's no acknowledge, basically. So WireGuard, this is why I've been harping on WireGuard for a little bit. It is a UDP protocol. And so sometimes you can just get around it by using WireGuard, point it at port 443, port 80, and get around a lot of things that way. Now, WireGuard is a UDP protocol, but what if UDP is blocked on 443 or whatever? You can actually tunnel UDP through TCP, and you can use that UDP tunnel. The process to set it up is almost the same as all the other things that we've went in the past, just different command line options. You can also combine UDP tunnel with WireGuard by basically doing that. That's pretty helpful too. So instead of WireGuard going out through UDP, you do TCP instead. Another thing you could do is to use DNS over HTTPS. How many of you guys are familiar with it? One of you? Okay. So does anyone know what DNS is?
Yeah, that we know.
Yeah.
And we know HTTPS as well, and then we heard about DNS. It's supposed to be secure, right?
No, it's not secure. It's actually plain text. DNS is completely plain text. So if you want to connect to youtube.com, but youtube.com is blocked, well, the firewall knows that you made a DNS query and asked what's the IP address of YouTube, and it can block that, it can identify that. So one way to get around it is by using a relatively new protocol called DNS over HTTPS. It'll use SSL encryption to encrypt that. And yeah, a lot of people who rely on censorship are not happy with that. Firefox even makes it the default, or I think they will soon, and it's going to break a lot of censorship, a lot of monitoring this way. Yeah.
Hopefully I'm not interrupting this. IoT malware, does it use anything anywhere near this sophisticated to tunnel out of the device?
Oh yeah, certainly.
It does.
Yeah, definitely. And so you penetration testers, Cobalt Strike has really good modules where you can switch out different protocols to tunnel things through. So if you want to make a C2, there's modules that you can use DNS to tunnel through. You can use domain fronting to tunnel through. And it's the same program fundamentally, but the traffic that it uses to communicate can be switched out on command. I don't know if Metasploit has something similar, but Cobalt Strike is a good option for that. And Cobalt Strike is using it, your malware is definitely using it, especially the more sophisticated variants. So for example, this is an example of doing a DNS query through HTTPS. So Cloudflare is the DNS provider, and then we're hosting it in form of a GET request. So we're asking, what is the IP address for Facebook, and I want the A record for it, and it'll return back to me as a JSON blob. We can see the connection is being made out to cloudflaredns.org instead of your typical DNS server. And then all the data that's returned is going to be encrypted. So you're not going to be able to read that either, as long as your firewall is not inspecting the traffic in line. The other thing that you'll want to do is turn on encrypted SNI. So SNI is a alternative protocol that is typically used to identify what site a request is going to. So for example, if you're hosting a site on a single IP address, say 1.1.1.1, but Cloudflare is on it, Cloudflare DNS is on that, you have multiple sites, multiple domains pointing at the same IP, in your SNI is where you specify what site you want to go to, even though you're connecting to just the single IP. Problem with that is that's also not encrypted. So there's a relatively new protocol, I think proposed a few months ago, that will encrypt it and put the public key on the DNS record. So this will help as well. The way this works, let's see. Oh, there it is. So here's how the SNI typically works. We can see the request is made out to cloudflaredns.com, but when we encrypt this, I guess the protocol is so new, WireGuard doesn't even decode it yet, or at least at the time. So we can see you want to obfuscate that as well. So if you're going to enable DNS over HTTPS, make sure you also enable encrypted SNI. And you can do that in Firefox. I think it's still kind of experimental. I'm sure they're going to roll it out for real, but you can do it in the about config right now if you wanted to. So kind of review of the DPI techniques. So if they're sending reset packets, you can try to drop those different ways. The GitHub projects that I show you will do this automatically. This is an example of IP tables, and you just drop everything. If they're poisoning your DNS, as in you're trying to make a request out to youtube.com, but then the DNS server replies with something else that's not YouTube, you can switch over to DNS over HTTPS, so they don't do that. You're not even calling out to the DNS servers anymore. And then you can also drop the reset packets like we mentioned before with the Russian firewalls. There are other things that you can do. You can obfuscate some of the traffic that goes through. And so all of these are different projects that will help do this. And they're mostly Chinese development things because they actually have a big incentive to work on these projects. I'm not really sure what it quite means, but a Chinese friend actually explained it to me. What they're doing is essentially making a local tunnel, and then through the local tunnel, they're encrypting the traffic that goes through and then sending the rest out just through standard HTTPS. But anything on the inside, even if you do inspect it, is going to be encrypted with whatever stream cipher you choose. Final trump card that you can do, if everything else is blocked, you can use domain fronting. So domain fronting is a technique you can use to borrow a high reputation domain, say drive.google.com. It's probably not ever going to be blocked. People use it for work functions. What if I told you you can use drive.google.com to tunnel traffic through? The way this works, you have to understand a little bit about how modern networks work. When you connect to google.com, typically you're not going to connect directly to that server. It's going to go through a CDN network, so they can cache pages, make it faster and whatnot. But that CDN is probably just going to be 1 or 2 IP addresses. So if multiple people are going to the CDN has to decide where to send that traffic to, and does that through SNI, like I explained before. Here's an example of using Bing to go to our site, projectpool.org. So as you can see, we're doing a curl request to bing.com, but in the header, we're specifying projectpool.org. So it's going out to the site for Bing, but once it goes to that CDN, I think it's at whatever site that's at. When it goes to the CDN, the CDN will then direct it to projectpool.org. So eventually the connection goes out through projectpool.org instead. That's an example that doesn't work pretty well, but the technique's still alive and going. I know a lot of providers are cracking down on it. How many of you guys use Signal, actually? Yeah, so a lot of you use Signal Chat. So in the settings, there's actually something called censorship evasion, censorship bypassing, something like that in your settings. So even if signal.org is blocked in a particular country, say Iran, Hong Kong, you can turn that on and it will try to bypass it using this domain fronting technique. So it's something that's used in production. Not only pen testers use it, there's a lot of legitimate things as well. Siphon Tunnel Core is another project that will help you build a tunnel using this technique. You set it up the same way that we set up all the other previous tunnels that we did before. Like I said before, companies are cracking down on it, but there are still domains that you can domain front, and even though they announce publicly that they blocked it, it turns out when they try to block this type of behavior, it breaks a lot of other applications, so they'll roll it back. So Google Drive is an example of that. They blocked it for a little bit, but customers started complaining, they rolled it back. Now domain fronting works on those as well. Define domain frontable domains. You can use this Python script, pretty helpful, and there are other resources here that you can learn more about domain fronting if you want to use it for yourself, if you want to use it for pen testing or whatnot. But almost guaranteed no one's going to detect it, because if you're looking at the firewall logs, it totally looks like you're just making a connection to google-drive.com, but it's actually your C2 server or your proxy server. That's it for my talk. The slides are posted on that GitHub link, and you can contact me by email if you have any questions. Thanks so much for coming.
Thank you so much, Kevin. Are you sure you guys don't have any questions?
I have a question.
Okay, go ahead.
On the domain fronting, it's the traffic going out looks like it's going to like drive.com, .google coming back. It would be
Right.
From the other?
It'd be coming back through the CDN as well. So if your CDN that's hosting Google Drive is 2.2.2, the traffic that you see is only going to be 2.2.2.2.
Oh, okay.
And the host header, if you're not opening it up and looking at that SNI, it's just going to look like Google Drive traffic.
Gotcha. Okay.
Very hard to detect.
Cool.
This is probably kind of an ignorant question just because I'm not pretty new at this, but it looks like a lot of this stuff, a lot of the attempts here are basically stuffing data into another protocol and relying on what's ever at the other end to recognize that there's that data there pulling it out.
Yeah, exactly. Yeah, that's absolutely correct. Yeah, any other questions?
What was that tool on the obfuscate traffic?
The slides are posted
Oh,
here.
gotcha.
Obfuscate traffic.
I think it was.
Oh, yeah, that one. So those are
Gotcha.
some of the good ones. The guy who actually worked on S proxy, I think, is a Chinese developer, and became a pretty popular project on GitHub. A lot of people were using it, and eventually the Chinese government found out about it. They actually went to his house, beat him, and made him take off the code off of GitHub. So it's serious over there. People have real skin in the game. Yeah.
How do I word this question? How many of these techniques do you have firsthand experience with, and how many of them would you like never even try to do that because you might get into trouble?
What do you mean?
So I guess the answer is all of them.
If you're asking, there are certain techniques that are less noisy than others, and there's going to be a performance trade-off. So ping is probably not going to go through very quickly, but it's probably going to fly underneath the radar. Domain fronting takes a lot of setup. You got to find your domain frontable things. You got to set up your
So, but you've tried all these techniques firsthand?
not all of them, maybe
Oh.
half of them.
Half of them?
Another half of
So
them.
half of them. And the other half, it was just a matter of time, or are you trying to avoid doing the other half because some of them might get you into trouble with someone?
Well, I don't live in China. I think I'm fine here. Yeah.
And he's a pen test, true.
Okay.
Yeah.
So you're safe.
I know.
As far as we know.
But if you use this on, say, your work and you get in trouble, not my fault.
Told me to do it.
Yeah.
You should put it on the first slide, right?
Yeah.
That is an excellent idea.
Disclaimer.
Probably
Use your own.
Yeah, just stick to the basic ones, say using web cache and whatnot. You can probably explain to HR, I guess.
Probably.
Yeah, on your way out.
For the DNS exfiltrations,
Yeah.
did you use DNS cut, and have you ever compared that to some other tools like Iodine? And what did you like?
Yeah,
about
so
that?
Iodine is really good. It's kind of a newer one. I don't think I got to it, but
Yeah.
I've read a lot about it. It
Yeah.
seems pretty performant. I think Iodine is a C# project, isn't it?
Yeah.
Yeah, the other one is Ruby, so it's not as portable. You have to have dependencies on your client and server. But with Iodine, say you land on a box, you can just execute that binary and then use that. So yes, good point. Iodine is very good. Okay, thank you guys.
Thank you.